right, class, let's start chapter 6 on graphing trigonometric functions. So we're going to start with the two main ones, graphing sine and cosine functions. And then in 6.2, we're going to move on and graph the others. Okay. So we've already seen that we are allowed to plug in any number inside a sine. In other words, what? Sine is a function of real numbers, not of angles necessarily. Yes, we look at sine, cosine of angle values, but that doesn't have to be. So for example, what does it mean to find sine of the number 2? As we saw, that's simply meant to do what? On the unit circle, you start at the point of coordinates 1, 0, and then what do? You move 2 units, this being the length of 1 unit. So if you go 1, about 1, 2, yes, 2 of these units along the circle, you're going to end up at this point. And then what do we pick? We pick the y coordinate of this point. That's what sine of 2 is equal to, right? It's the y coordinate of this point. So how do you find the y coordinate? One more time, you look back to the y-axis, right? Then you read this value. And so on and so on. You want to find what? Sine of -3. That means what? You start on the unit circle here at the point of coordinates 1, 0, and you move what? About 1, 2, 3, well, I know it's units in a negative direction, yes? So wherever you land, this, you read the y coordinate, right? So the y coordinate of this point is sine of -3. Okay, put in your calculator. So, of course, that is the same thing as what? Being on any circle, yes, of any radius r, and having to figure out the sine value of 2. So you're going to move by 2 radians, right? This is 1 r. This is a second r. Yes, 2 radii. That's 2 radians. Yes. So there you go. That's 2 radians. And then you just pick the y coordinate of this point, and it's going to be the same thing as moving alongside the unit circle. So sine of 2 is really the same thing as finding sine of an angle of 2 radians, right? Okay. All right. So put in any value you want. That simply means we got ourselves a function. What is the domain of this function? All real numbers. Put in -5,000 and just keep going around that unit circle, -5,000 units until you've gotten completely dizzy and you landed on a point. Yes. The question is, what's the range? The point is, no matter what, what's going to happen? Wherever you land on the unit circle, you keep reading the y coordinate, yes? And you keep reading the y coordinate. The y coordinate is definitely only going to range between what and what? -1 and 1. You can't go higher. You can't go outside of the circle, right? You land on a point on the unit circle and keep reading the y coordinate. So it's always going to range in between -1 and 1, right? You land at this point, you got yourself a 1. You land at this point, you got yourself a -1, but no past that. So these are the range values. Okay, let's see if we can come up with a graph based on this. Okay, so I already know I'm not going to go past 1, and I'm not going to go past -1, yes? So let's see what sine of 0. Sine of 0 means you haven't moved at all, right, along the unit circle. So what's the y coordinate of this point? The y coordinate of this point, where I haven't even gone 1 bit, is 0. So sine of 0 is 0. Then what happens to these y values? They keep getting higher and higher, right? Up until, what's this angle here? Pi over 2. So at about pi over 2, I reach the value 1. Okay. Then what happens to these y coordinates? They go down, yes? The y coordinates are going to keep going down until I reach this point here, which is pi. And what's the y coordinate at this point? Back to 0. So at pi, I'm back at 0. Okay. And then what happens to the y coordinates? They go down lower and lower to -1. When did I reach this -1? At pi, 3 pi over 2. So at 3 pi over 2, I reached this number, -1. And then the y coordinates are going to go back higher and higher until I get to 0, right? So when do I get to 0? At 2 pi again, okay? So here it is. This is one complete cycle of the sine function. What you have to do is kind of keep it nice and even. I think I should have gone a little lower, but there it is, okay? Now, why did I say one complete cycle? Because what happens after 2 pi? We're up to 3.14, so 6.28. So once you put a number more than 6.28, you the second time around the circle, what happens to the y values? They go up to 1, back down to 0, down to -1, back up at 0, okay? So what we say is that the sine function is periodic and it has a period of 2 pi. In other words, what? This whole thing is gonna now repeat again, and I should have made it smaller, but I'll go this way. Trying to keep my units. -2 pi, -3 pi over 2, -pi, and -pi over 2. What happens with this is just gonna repeat. And on the sine function goes, okay? So it's periodic, it repeats every 2 pi. What did I show you here? That if I go in a negative direction, right? I'm first going to go down to -1, back up at 0, back up at 1, back up at 0, okay? Back down to 0, I should say. All right, so the sine function is periodic. In other words, what does it mean? Its y values repeat every period, and our period is 2 pi, okay? So let's talk about a few other things that this sine wave will have. It has what's called an amplitude. So the amplitude is the distance from the midline, which I'm going to show you what the midline of it is, to the highest point or the lowest point. Now, since it's a midline, then it doesn't really matter if you go to the highest point or the lowest point. So as you see, the midline for this graph is the x-axis, yes? And what happens to the graph? It goes 1 unit up, 1 unit down, 1 unit up, 1 unit down. So this right here is the amplitude, right? How high do you have to go? It's centered around the x-axis, yes? Keeps going up and down around the x-axis. 1 unit up, 1 unit down. So, sure enough, the amplitude for our graph is 1. Okay, so even though it goes 1 unit down, at times we don't say -1, right? The amplitude is the distance, so it should be positive. Okay, all right. The period, we already said, how often does the graph repeat, right? How often does the graph repeat? And for our sine function, every 2 pi. Yes, so the period of the sine is 2 pi. You went 2 pi, and then you take this and copy and paste it over and over and over again. Okay. Phase shift and vertical shift. Of course, we're going to mess with this graph like we've learned to do in chapter 1 with all our basic graphs, right? Then stretch it and move it, shift it left, up, down, and so on and so on. So in other words, what is going to happen? We're going to stretch this graph vertically. We're going to mess with the amplitude. we're going to shrink or stretch this graph horizontally, we're going to mess with the period. Yes, but we can also take this cookie cutter and move it where? Up, down, left, and right. So the first phase shift is just simply going to be told, the phase shift we call the horizontal shift. From the origin. It's easiest to start from here, right? So it starts at the origin, and if it doesn't start at the origin, I'm moving this point, right? Left, right, whatever the horizontal shift is. And the vertical shift is the vertical shift off the midline, up or down. So the vertical shift really is the same thing as your midline. So obviously a regular sine function has no phase shift, right? Starts at 0. We're not moving it yet. And the vertical shift is y equals to 0 otherwise, right? The x-axis. That's the starting midline. If I should move this graph some units up or down, then obviously the midline's just going to move up and down with it. So we're going to see all this. So the point is, when we graph at least when we graph a sine function or a cosine function, all we're going to have to do is graph what? One complete cycle. And this right here is one complete cycle, right? Because what happens to it afterwards? It's just going to repeat. So the same wave, this is a sine wave. This is what a sine wave looks like. And then it just repeats over and over and over again. So we're going to draw one complete cycle, and then once you have one, what can you do? Copy and paste it over and over and over again along the x-axis. So that's one complete cycle. Now, for this one complete cycle, if it's not just the, I mean, obviously we're not just going to graph sine of x. That's boring. We're going to shift it, stretch it, and so on and so on. So these shifts and stretches simply are going to be a matter of, does the amplitude change, period, phase shift, and vertical shift. So we're going to go over this. Now, before we take the sine function anywhere, let's look at the cosine function. So what's the domain of the cosine function, and how do I find the cosine of anything? Remember, what does the cosine of 2 mean? The cosine of 2 means to pick the x-coordinate of the point we're landing on. So it's the same thing. If I want to find cosine 2, I go along the circle. Yes, I pick the x-coordinate. That's the cosine value of it. Yes. If I want to find cosine of -3, the same thing. From this point of coordinates 1, 0, I'm going to go, 1, 2, 3 units, right? And then what do I pick? I pick the x-coordinate of this point. And what does it mean to pick the x-coordinate? Well, look back to the x-axis, right? You landed at this point, look back at the x-axis, pick that x-coordinate, right? That's how we read the points. Okay, so it's the same thing here. To find cosine of 2, it's the same thing as finding the cosine of 2 radians. So you landed at this point right here. Again, the x-coordinate of it is cosine of 2. The y-coordinate of it is sine of 2, right? Radians, or just simply the real number 2. Okay, so the same way, the domain, put in any real number inside your cosine function. So I'm going to stretch it left and right all the way. The range, same thing. Those x-coordinates will not go past 1 or -1, right? So whatever x-coordinate I pick, I can go past 1 or I can go past -1 because it's always a point on the unit circle, right? So all I'm doing is just reading the x-coordinates of these points. That's all. All right, so let's see if we can draw this graph. What is cosine of 0? So you are down here at 0, right? You haven't gone at all from this point, so 0 distance. What's the x-coordinate of this point? That would be a 1. So cosine of 0 is 1. We're starting the graph there. Okay. Then what happens to these x-coordinates? As I move along the circle, right, from this one, these x-coordinates are going to go closer and closer to 0, right? When do I reach that value 0? At pi over 2. So the x-coordinate of this point at pi over 2 is 0, yes? Then what happens to my x-coordinates as I move along the circle. The x coordinates are going to go down to -1. When do I reach that value? At pi. Okay. Then what happens to my x coordinates as I move along the circle? So these x coordinates are going to get closer and closer to back down to 0. So when do I reach that value? When I'm at 3 pi over 2. I'm back at 0. And finally, what happens to my x coordinates? My x coordinates will move further and further down to 1. And when do I reach that value of 1? At 2 pi. I'm back where I've started. So here is my graph. Don't make it a V, don't make it lines, it's curvy. So in other words, this is one complete cycle of that cosine function. Okay. Starts at 1, gets back to 1. And then what do I do with it? I can copy and paste it, yes? So I'm going to keep my units even. Negative pi over 2, negative pi, negative 3 pi over 2, about negative 2 pi. So a cosine function starts at 1, back down to 0, down to -1. Whoops, what did I do? 0? Yeah, and back up to 1. Boom. I cut and pasted another complete cycle. I want to go this way, 1, 2. By the way, each one of these represents one of your quadrants. So another pi over 2, another pi over 2, another pi over 2, and another pi over 2. Go back to 0, down to -1, back up to 0, back up to 1. Another complete cycle. And this just keeps going and going all the way, right, into negative infinity and positive infinity. Just copy and paste one complete cycle of cosine. So same thing, one complete cycle of cosine will have an amplitude of 1, right? A period of 2 pi. And again, what do I mean by amplitude? I mean from the midline, right? It's centered up and down along this x-axis. So how far do I go up? 1 unit up, 1 unit down. The highest, right? So the highest distance to the highest point. So the most 1 point up, 1 point down. It repeats every 2 pi, right? So one complete cycle can be done 1 time around the circle. Of course, there's a phase shift and a vertical shift for a regular cosine function that's starting at 0. We haven't moved it yet. Okay, so to graph any sine or cosine function, this is all we have to do. So we have to simply complete one cycle, and if we need more, we're just gonna cut and paste it and keep drawing that. To figure out the complete cycle, we need to figure out the amplitude, period, phase shift, and vertical shift. Okay, so we're gonna start simple. 2 sine of 2x. What does that do to the graph? Now, this number 2 that multiplies to the function, that's a what? A vertical stretch by a factor of 2, yes? So a vertical stretch means what? I'm going to make my graph, and of course it's a sine function. So what does it mean, a vertical stretch? I'm going to pull this graph, multiply by a factor of 2. The y's of 0 still stay 0, yes? But what's going to happen, this y of 1 is going to go to 2. So what this number 2 does, this vertical stretch, simply messes with the amplitude. So the amplitude's going to go to 2. What does this number here mean? The 2 times x. The 2 times x means take all the x values and divide them by 2, right? So what does that do to the graph of sine is that it shifts all the x values you're going to get just to half of what they were. So what that does is messes with the period. So it shrinks the graph by a factor of 2 horizontally. So that's a horizontal compression because it's dividing by 2, right? It's the opposite. By a factor of 2. So what that does is messes with your period. So your period of 2 pi now gets divided in half, so the period is now only pi. Nothing's added to the function, nothing's subtracted, there are only 2 transformations. So what does that mean? And by the way, you can really copy and paste a sine wave. The labeling is the most important thing. It's going to look the same, but it's going to cross at different points. So what is now my amplitude? 2 to negative 2. So in other words, the graph is going to go as high as 2, as low as negative 2. What's the period? Pi. So this could be just the same as any sine function. That if I wrote the 1 and a negative 1 and a 2 pi here, it would just be a regular sine function. So all I'm saying is it looks the same, your labeling will be different. So it goes as high as 2, as low as negative 2. The period is only pi. So what you've done is, once you've figured this out, you cut this into 4 equal parts for your 4 quadrants. Yes. So when you cut this in half, you get halfway to pi. Yes, that's a pi over 4, and that's a 3 pi over 4. So a quarter, 2 quarters, 3 quarters, 1 full thing, right? So what does the sine function look like? The sine wave starts at 0, goes up at 1, back down to 0, down to negative 1, back up at 0. Except for now, the amplitude changed to a 2, and we're only going as high as pi. So again, this looks just the same as any sine wave, right? The only important thing is the labeling now changed, right? It's not just going to 1 and negative 1 and as high as 2 pi, right? It shrunk by a factor of 2, and it got stretched vertically by a factor of 2. So the amplitude change and the period change. There is no phase shift, so the phase shift is still a 0. We haven't taken this point off anywhere. And the vertical shift is still a 0. So in other words, our midline is still y equals to 0. We didn't take this graph and move it up and down. Okay, there it is. Now, if we need to graph this more, what do I simply do? Take this, copy and paste it. Yes. Copy and paste it over and over again, right? One more period is going to be another pi, so it repeats to the 2 pi, right? From pi to 2 pi, you get one more complete cycle. Okay. All right, let's try one more sine, and then we'll graph a cosine. So what I've picked now is I didn't multiply the sine value by anything, and I didn't multiply the x value by anything. These are now total shifts. So what's the amplitude? Nothing got multiplied to the sine, so I'm now changing that vertical amplitude, right? So I'm just leaving it the same. Nothing is multiplied to the x, so the period is still 2 pi, okay? But what we've changed is that we are having the x values. We subtract pi from the x values. What does it mean when you subtract something from the x? That means you have to shift it 1 unit to the right. So what we did is now the phase shift is a pi. And what else happened? We're adding 2 to the whole sine function, so that's a vertical shift. So we have a vertical shift that is 2 units up. So in other words, your midline moved to y equals to 2. Okay. How will we graph that? Well, let's see. So what we're saying is that the midline moved up to y equals to 2. Yes, so we're taking this graph and moving it 2 units up. And what's the amplitude from here? The amplitude is 1. So from this midline, we're only going 1 unit up and 1 unit down. Okay. The period is still 2 pi. But we have a phase shift of pi. So what are we doing? We're taking this graph pi units to the right. But then we're still keeping it, 1 pi, 2 pi, 3 pi. I'll show you a different way. So the period is still 2 pi long, right? So to go from pi to 3 pi, that's a 2 pi distance. So we're taking our graph and we're simply shifting it 1 unit, pi units to the right. And after that, it's all the same. So let me show you exactly how I would get this graph from the beginning. What does the sine look like? It starts at 0, goes, so this is my full range. I need to cut it into 4 equal parts. So that's halfway. Halfway to this is 3 pi over 2. Halfway to this is 5 pi over 2. So I'll show you how I got those numbers. So now I'm going to graph it. What does the sine do? Starts at 0, goes up to 1, back down at 0, down to -1, back up at 0. That's one complete cycle. Done. What can I do with it? Right? Looks just like a sine function. Looks just like a sine wave. So get used to that idea. The question is, where do you move it? Okay. So, in other words, this could have looked just the same as what? As a regular sine function, yes. If I would have started it at 0, 0, right? 2 pi distance, except for what? We moved everything. So we just shifted it from 0, 0 up there. Where do we shift it? 2 units up, pi units to the right. Yes. So when you graph a sine and cosine wave, of course you could have started it back at 0, go up to 1, right? Back down to 0, down to here, and then what do you do with this original graph of sine of x? You take this original graph of sine of x and move it 2 units up. Yes, so now it's going to stay here, go all the way here. So this is a sine of x plus 2, right? So take the graph, move it 2 units up. Then what do? We take this graph and move it pi units to the right. Yes, so from 0, moving it to pi. Yes, and this moves another pi over to the right. So we're taking this, move it up and to the right, or fine, to the right and up. It's the same thing. So this is your graph right there. Now, all you have to do is figure out what's the initial point, what's the end point of your one complete cycle. Yes, what's the amplitude, right? From this initial point to the end point, cut it into your 4 equal parts, right? Goes up to 1, back to 0, -1, back up to 1. Wherever your 1, and I'm saying 1, 0, -1 because that's what a sine function is. But here it could say anything, depends on what the new amplitude is, right? So yes, the amplitude was still 1. So from here we went 1 unit up, right? 1 unit down. Another easy way to figure out the beginning, that's going to be a tricky part, to figure out the start point. The phase shift basically is always your start point, right? So from 0, where did you shift this graph? So one easy way to figure out the beginning and the end point is this. What's inside the sine? And this is going to be even better when more things are happening to x. So what's inside the sine is x minus pi. Now, a normal sine is always drawn between what and what? Between 0 and 2 pi, right? That's a regular sine function. So a sine function is one cycle of it is graphed between 0 and 2 pi. So all you have to do is solve this double inequality for x. So to solve for x, what do? I'm going to add pi to all 3 sides. So in other words, my new graph, my one complete cycle, has to be starting now at pi and ending at 3 pi. Just as you see it, it starts at pi, it ends at 3 pi. That's one complete cycle of it. So that's one quick way, especially as I said, when things get complicated, that's one quick way to figure out where do you start it, where do you end it. Okay, beginning and the end. All right, so we're going to continue on the next video.